Hello, students, and welcome to Math Weekly's number 11.
In this Math Weekly, we are going to be focusing on transformations on a coordinate plane. A transformation, by definition, is a change to a shape's position or size. There are different types of transformations. There are three types that will change a shape's position. They are translations, rotations, and reflections. And there is one type that will transform a shape's size, and that is called a dilation. Translations is our first type of transformation. A transformation slides a shape's location along a path or paths. Let's look at an example where we are going to translate this shape 3 units left and 4 units down. To do this, we will actually make 3 movements, one for each of the 3 corners of the triangle. So let's begin here at the top corner, which we're going to call point A. We need to move point A 3 units to the left, so here's 1, 2, 3, and 4 units down. 1, 2, 3, 4. This is the new location of point A. We need to do the same thing for point B. 3 to the left, 1, 2, 3, and 4 down, 1, 2, 3, 4. This is the location for point B. Now we need to lastly do the same thing for point C, the last corner of the triangle. 3 to the left, 1, 2, 3, and 4 down, 1, 2, 3, 4. You can see that this triangle's size was preserved. It is still the same size as the original triangle. It's just that it's been moved to the left 3 and down 4. Our second type of transformation is called a rotation. A rotation turns a shape around a point, usually the origin, but does not always have to be. We're going to do an example where we're going to rotate that same triangle 90 degrees to the right around the origin. In other words, this triangle is going to end up down here in this quadrant, in quadrant 4. The easiest way to rotate a shape is to do the opposite of the ordered pairs that exist. So let's begin with A. A is over 2 and up 6. So do the opposite. Go over 6 and down 2. This is now point A. Notice A was to the top right, or to the top, and now it's to the right, which makes sense because it turned to the next side. Point B is over 2 and up 1. So we'll have to go over 1 and down 2. This is now point B. And lastly, we have point C. Point C is over 5 and up 1. So we'll go over 1 and down 5. So right here is C. And once again, the size has been preserved. It had a base of 3 units in both, and it has a height of 5 units. The top is at the unit 6, just as it was up here. It's 1 away from this axis, and it's 1 away from this axis. So there are a few ways that you can check. Another way that you can check is to start with where you rotated around, which in this case is the origin, and connect 2 of the same letter, B to B, and it should make a 90-degree angle. The third type, and the last type that preserves the size of the figure, which means it just changes its position, is called a reflection. A reflection creates a mirror image over a line of reflection. An example would be to reflect this triangle ABC over the y-axis. To do this, use the y-axis as a mirror. So point A is 2 away from the y-axis, so a reflection of it would also be 2 away, just on the other side. B is also 2 away, so it would be 2 away on this side. C would be 5 away, so it needs to be 5 away on this side. So C looks like this, and you notice it's the same size as it was before. It is just in a different location. It's now in quadrant 2 rather than being in quadrant number 1. The last type of transformation, and the only type that changes the size of a figure, is called a dilation. A dilation creates a scaled image. A dilation smaller than the original figure is called a reduction. A dilation larger than the original figure is called an enlargement. A dilation factor describes how much larger or smaller the dilation is when compared to the original figure. A dilation factor greater than 1 creates an enlargement. A dilation factor less than 1, which would be a fraction, creates a reduction. A dilation factor can be created by writing a fraction of the two corresponding sides, the dilation size over the original size. So what dilation factor was used to create triangle A1, B1, C1 if this is the original triangle? Well, remember, a dilation factor can be written by looking at corresponding sides. Always try to use corresponding sides that align with the axis. So in this case, we're going to use segment AB and segment A1B1 because they're both horizontal lines. If they were vertical lines, such as something like this and this, we could use those as well because we can count the number of boxes. Avoid using the diagonals because we do not know diagonal distance unless we do the Pythagorean theorem, which just creates more work for yourself. Now, the dilation factor needs corresponding sides, and it's always the dilation size over the original size. Well, in this case, the dilation size goes from 6 to 15. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks. So the dilation size is 9 units. The original size is 1, 2, 3. It goes from 2 to 5. So that's 3 units. So as a fraction, that's 9 over 3, which reduces by 3 to 3 over 1, and 3 divided by 1 is 3. So there was a dilation factor of 3 used here, which makes sense because this is an enlargement. And remember, enlargements have dilation factors greater than 1. So let's summarize what we've learned. A transformation is a change to the position or size of a shape. There are 4 types of transformations. A translation means to slide. A rotation means to turn. A reflection means to create a mirror image or to flip. And a dilation means to create a scaled version, always an enlargement or a reduction.